Well, good afternoon, everybody. I want to thank you all for coming to this event as part of Alaska Startup Week here today. So Alaska Startup Week is a week-long of entrepreneurial innovative events across the state of Alaska, both in person and virtually, depending on the location. So today we're here part of a panel, and in a moment I'll be passing over to David Park to talk about the Technology Transfer Office here at UAF and the presenters and panelists that we have today. But before we do that, I just want to remind you that it's centralized here with the Innovation Hub within UAF and part of the University of Alaska that's putting on and hosting the event today. And we're part of this hub system that provides education, funding and support for entrepreneurs and innovators, both within the university system and externally. And also I'd like to recognize the traditional lands that we are currently residing upon here in Fairbanks, the land of the Denana people of the Lower Tanana River. And for those calling in from around Alaska and the US, you are also on traditional lands, and therefore we recognize the current, past and future caretaking of those lands. So on that note, I'm going to pass over to David Park from the Office of Intellectual Property and Commercialization to lead us through the event and introduce our presenters. So over to you, David.
Thanks, Peter. My name is David Park. I'm a program manager here at the Office of Intellectual Property and Commercialization. And this is going to be a panel discussion from our Ideas Awards winners, which I'll discuss a little bit more, just to introduce our office and the Ideas Awards. So next slide, Peter. Our office engages in technology transfer, the idea that transferring research results from the universities to the commercial marketplace for the public benefit. And Center ICE, the Center for Innovation, Commercialization, and Entrepreneurship here, offers services such as innovation, acceleration through seed funding, customer discovery, mentoring, networking, and even ideation events. So that's the whole idea of our office engagement. Next, Peter. This is just some of the pictures from our offices, and it includes even a Hall of Fame wall in the center located at University of Alaska Fairbanks. Next slide, Peter. So part of this steps of technology transfer begins with ideation and disclosure of innovative ideas from the university staff, faculty, students. And our office also evaluates those ideas, protects intellectual property in some cases, and then tries to provide a way to transfer that out of the university to the marketplace or for societal benefit through licensing or through partnerships with industry. So the second part of this is the Ideas Awards, where it stands for the Innovative Disclosures and Entrepreneurial Activities Awards, that we're recognizing disclosures, innovative solutions from the UAF and UAS campuses for the academic year. And previously, all Ideas Awards winners were recognized for their innovative approaches to research, teaching, and service. And really, it's from faculty, staff, graduate students, undergraduate students, and we also awarded for the best overall innovation. And just because you're here on this call, I'll let you in on some of the metrics that we used. I don't think we actually publicly disclose the metrics that we use for the awards, but the 5 metrics that we used in the past was for commercial readiness, the potential market size, the impact on society or community, and the strength of the team and the strength of intellectual property. So those were some of the metrics that we used to make the awards for the disclosures. And this past year, it really, there was such a diverse areas of innovation, and it included biotechnology, a fuel vent to stop oil leakage, social vulnerability mapping for diseases like COVID, even waste pipe water connectors for the Arctic to deal with permafrost. And a past winner from 2019 are Tom Marsick and Riley Bickford, and one of the award winners from this year was Jeffrey Wheat. So I just want to really thank the panelists for joining us today. As by way of introduction, Tom is an associate professor of sustainable energy at UAF, and he's also part of ACEP, the Alaska Center for Energy and Power. He's also the research director at the Cold Climate Housing Research Center. Riley is a master's graduate student, and he's been working on this project, which they'll discuss further with us, with Tom. And he's also a part of ACEP. Lastly, Jeff Wheat, he's a full research professor in the Institute of Marine Science as a part of our CFOS, College of Fisheries and Ocean Sciences. And he specializes in low and high temperature geochemistry, hydrogeology, and borehole fluid samplers, those kind of instrumentation needs. So with that, I'd like to ask, I think Tom and Riley are going to do the first presentation, is that correct?
Yeah, thank you very much for the introduction. And I want to say thank you very much to all the organizers of this exciting event. Like David said, I'm Tom, and I have a joint position between the University of Alaska Fairbanks and the Cold Climate Housing Research Center. And I've had the pleasure to work with Riley, who you will hear from in just a little bit, and the rest of the team, as shown here, on an invention that we call the Arctic Dual Hood for heat recovery ventilation. And before Riley tells you about the invention, I want to give you a little bit of a background about what heat recovery ventilation is, and also a little bit about the process that we went through as we worked on this invention. Next slide, please. So we like to ventilate buildings to bring in fresh air and exhaust the stale air. So to maintain good indoor air quality. But of course, the problem in cold climates is that as we are bringing the fresh air, that's in winter, it's cold, and we are exhausting the warm stale air to the outside, and we can potentially waste a lot of energy. And that's why often we like to use this device that's called a heat recovery ventilator, an HRV, that does the same thing. It brings in the fresh air from the outside and exhausts the stale air to the outside. But it has a heat exchanger in it, and it is in this heat exchanger, as the warm stale air is going out, the heat from that is being transferred into the fresh cold air that is coming in. So we can achieve a superior indoor air quality without a significant heat loss. So as you can see on this drawing of the HRV, it has 4 ports, 2 that connect the unit to the outside, so 1 for the fresh air intake and 1 for the stale air exhaust, and then 2 on the warm side to deliver the fresh air to the building, and then the return port where the stale air is returning into the device. And as you can see on the picture below, to connect the unit to the outside, we need 2 penetrations through the wall. So 1 for the fresh air intake and 1 for the stale air exhaust. So you can see the 2 hoods on the picture, and that's not very practical to have to make these 2 penetrations in the wall. They have to be a certain length apart also. And so there is a product on the market, next slide please, that's called the dual hood. And you can see the dual hood up here on the picture, and that combines the intake and exhaust into 1 wall penetration. So you cannot really see it on the picture, but the intake goes from the bottom, so that's where the fresh air is taken in, and then the exhaust in the upper part, and that's where the stale air is exhausted. But the problem is that this product that exists on the market tends to freeze up in cold climates. You can see it on the picture below. As the stale air is going out, it has moisture in it, and it's freezing up, and it can completely freeze shut, which means then the dual hood no longer works. You can no longer be exchanging the air and providing superior indoor air quality in the building. And so we came up with a design that we believe overcomes this issue. Riley's gonna tell you about it in just a little bit, that we call the Arctic dual hood for heat recovery ventilation. But before then, I just want to tell you about the process of how we got to work on this invention. So working with the Cold Climate Housing Research Center, we kind of keep a list of ideas as we learn about problems. We keep a list of ideas that could potentially solve the problems, and so it has been a known issue that these dual hoods freeze up in Alaska. And so one of the many ideas on the list was to develop a design, a geometry, and that would overcome this problem of freezing up. And Riley was an undergrad student at UAF, and he was looking for a project for his class. And so he came by my office and explained what he was interested in, and I showed him the list of various research projects, and I asked him which one he would be interested to work on, and he chose this Arctic dual hood as a project to work on. So it started as a project in an undergrad class, and shortly afterwards we went through the process of the invention disclosure through the Office of Intellectual Property and Commercialization, and their support was very generous. So ever since we started interacting with the YPC, they really provided a lot of support to lead us through this process and provide resources and guidance to go through the process of developing this invention, and even now through the stages of intellectual property protection. So right now YPC is again continuing to generously support us and helping us with the provisional patent application. And so when Riley finished his undergraduate class and the project as a part of that, he then continued working on this invention and started a grad school and chose this project for his thesis in his grad school, and that's how this project continues to be getting the attention that it deserves and is being further developed. And I'm gonna let Riley tell you about this project and what this Arctic dual hood for heat recovery ventilation is about. So Riley, it's all yours.
Thank you for that introduction, Tom. Yeah, so now I'm in my master's program, pursuing this as the topic of my thesis research. And if I could get the next slide, Peter. Yes, thank you. Just a broad overview of what our plan here and including some of what we've done already involves the development of prototypes, which we test and evaluate, Arctic dual hood prototypes, that is, that we're evaluating to make sure that we have a design that can perform in cold climates while meeting the requirements of a dual hood. And then that kind of blurs together with the next step of testing. That's just part of the iterative process of designing, evaluating, and redesigning if necessary before moving on to the next steps. And our plan is to pursue intellectual property protections, which will allow us to then license our design for manufacturing and distribution, assuming we're successful in each of the previous steps. But there is a little nuance here in that, again, the prototype development does involve testing, and that intellectual property protections, at least for the purposes of our project, we plan to split into getting a provisional patent first, which courtesy of David Park and the Office of Intellectual Property and Commercialization at the University of Alaska Fairbanks we're currently working on. And on down the road, when we have a final design, we plan to get a non-provisional patent, which will then can be licensed. Could I get the next slide, Peter? So our work so far, we are still in those first two steps of prototype development and testing. As Tom mentioned, a dual hood needs to handle the exhaust and the intake air of a heat recovery ventilation system at basically the same location in a building. And that has a risk for contamination. And so we need to design against that while also allowing the dual hood to function in cold climates. So we are designing against frost accumulation and contamination. For the frost accumulation, we have used two separate testing methods, broadly speaking. One, we have used actual heat recovery ventilation systems with a heat recovery ventilator, and we have conducted side-by-side tests that allow us to compare our design with each other for the iterative steps and to the commercially available dual hoods in the real world. The problem that we encountered with that was that weather conditions change, so the conditions of our test change. And to stabilize that, we brought our designs into a climate chamber, which there's a picture of me on the right there, inside of a climate chamber with an apparatus that we needed to design in order to evaluate dual hoods. Pictured there is a picture of a commercially available dual hood that we're evaluating. And so that allows us to watch frost accumulation and evaluate it, quantify it, and that informs the next iterations of our design. We do plan, coming soon, to bring our designs back into the real world for more testing with real heat recovery ventilation systems. The next thing we need to evaluate is contamination, where the exhaust air is pulled into the intake, and we need to prevent, at least to a large extent. And that we are doing with tracer gas systems to dose our exhaust and measure the intake to ensure that, well, we're shooting for less than 10% cross-contamination occurring there. And lastly, we have considered manufacturing consideration, or we have considered the needs for our design to be manufactured, and we are implementing those into our design. If I get the next slide. On to those, the next steps from a few slides ago was our plan down the road to get our intellectual property protections, which we can then license. And we would need a large manufacturer and distributor to push this along. And an interested company that we are working with under a non-disclosure agreement is Panasonic, who already have an interest in ventilation products that are focused on colder climates, and they are our current partners on this, and we hope to see this through with them. But could I get the next slide? I think that sums up what our project is and our work so far, and what we're headed to next. But we'll get into questions at the end of these presentations. So back to you, Peter.
Riley and Tom. And on that note, great to hear how you've developed and the directions you're going, and some of the collaborations and partnerships that you're already developing. It'd be interesting to talk more in general, both yourselves and Jeff, as you're moving forwards, about what are some of the capabilities that the statewide ecosystem can do to help and pursue some of those, whether it's opportunities, collaborations, connections, and that can be things you can bring up beyond just the participants today, because we'll be sharing this wider across the statewide ecosystem for those that weren't able to attend today. So if there's something you can think of as you're listening to Jeff's presentation that we as a community could help your project and your design move forwards, then please do bring those up in the discussion, because that's one thing about the entrepreneurial ecosystem, is it's a little bit about, it's about giving back, how we can move forward together, whether we are experts in that field, to bring our connections and our collaborations to the table. So on that note, I'm going to bring in Jeff Wheat's slides and the work that he's been doing with his multi-temperature fluid sampler, and pass it over to Jeff for your presentation.
Yeah, thank you very much for having me. I'm an oceanographer. I go to sea to do most of my research. Some of the times I'm on scientific drilling vessels. And one of the aspects of drilling into the deep ocean is as you drill deeper, the crust gets warmer. And what we're finding is that microbes are living in the deep subsurface, and there's more microbes in the subsurface than, and the diversity is greater than even like the Amazon rainforest. So one aspect is being able to quantify what the thermal limits of life are, what water rocket reactions are occurring, because this is how minerals get transferred, metals get transferred and precipitate by these exchanges, and also understand better the diversity of the global basaltic biome. So that's a picture on the right of the scientific drilling vessel that's operated by the US. And the rig floor right there. Next slide. So one of the problems is that at temperatures greater than 150 degrees Celsius, electronics don't do very well. They typically fail because some component just can't handle the temperatures more than 150 degrees. In many cases, it's the batteries that go first, but somewhere along the lines, things fail. So our solution to this, to get why we wanted to go over 150 degrees Celsius, is that microbes have been grown in the laboratory at 122 degrees Celsius. There's some indication that microbes can survive to 150, and there's some anecdotal evidence that suggests that they can even survive up at 180 degrees Celsius. And so what we want to be able to do is collect some of those fluids and see if microbes are viable at those different temperatures. So with the issue and the problem of having the electronics fail at more than 150 degrees, we decided we'd try a purely mechanical triggering mechanism using shape memory alloys. And shape memory alloys are metal alloys that you can deform at room temperature and at a specific temperature based on the metal alloy and their shape will convert back to the original shape. So we developed a variety of these as triggers and tested them out in a variety of different ways. Next slide. And what we did was we had a whole bunch of criteria for the sampler itself, design criteria based on the science as well as operations on the drilling vessel to get it down the borehole, and also to fit with the triggering mechanism using the shape memory alloys. The next one. So where we are right now is we're gearing up to go on IODP Expedition 399. It'll happen in the spring of 2023 in one of the deepest boreholes in the Atlantic. And then we'll go hopefully to another deep borehole in the Pacific in 2025. There's a picture of the sampler lined up on the left. It's called on the catwalk. The rig floor is where the red is further up. Each section is a sampler. They're about a meter and they're about a meter long. And right there, we've got 11 of them lined up and ready to go with 11 different triggers, all at pre-specified temperatures ranging from 80 degrees Celsius to 185 degrees Celsius. However, when we set this up, we were never able to get back in the hole, so we never were able to try it out in the particular hole we wanted to. So hopefully we're going to go in 2023 and actually get it there. And this is interesting from the standpoint of science, from the standpoint of commercialization. The next step would be to develop one with a trigger using for a gas type version. This would be of interest to companies such as Schlumberger, which is a company that spends a lot of effort taking samples of boreholes and monitoring boreholes. And in 2020, they had a revenue of $24 billion. So this system, if it was in a gas type version, would be of viable interest to them because it would cut their costs drastically with the number of people that they'd have to send to sea compared to what they currently have to do. So that's about it.
Great, thanks for that, Jeff. It's interesting to see sort of some of the approaches that you've been able to do, and also that you've got some ideas of where you're going to do some future testings and future expeditions where you can take these developed solutions and actually get them out there. And one question I'd have, and we can bring that up, is what could be done? Is there any environments where you could be testing these where you're not going to have to be at sea, and whether there's a laboratory-based experiments that could be done? And maybe that's something to talk about, just like Tom and Riley were showing, where they were in that cold room doing some testing of whether there's potential to do, especially if you're moving in, if there's interest to go into the oil and gas side, what could be done prior to going into the field in some technology developments. So we've got the rest of today for any questions from the audience, any questions from myself, Kevin, and David to the presenters, and then questions that they might want to ask each other, having being within an academic environment, Riley's experiences of doing this as an undergraduate, where he was working with Tom, whether there's ways that students could connect to Jeff from within the engineering program to work on some of these developments. Maybe Riley can talk about sort of how he worked upon this as part of his undergraduate research. And then how can we as a community support these? Jeff brought up the one example of being able to make connections into some of these large multinational organizations. David at the very beginning was talking about some of the programmings that we have within Center ICE that could even help support people to do that. So the first sort of 4 questions here, you've all done an excellent job describing sort of what you were looking to solve, and either it was something you were seeing and seeing a need, or something that you actually were performing out in the field and were like, no, we need to have an improved way of being able to ensure that we can operate and continue to collect what we need to. So I guess my question is, what can the statewide community, so this is both within the academic environment and across Alaska and maybe across the Pacific Northwest, what could the statewide community do to help you move forwards? Is it you're looking at collaborations, you're looking for personnel to help work on the designs, whether it's the next version or the current version? What are some of the needs that you and your groups have to help move this forwards, and to be able to either move it into a licensed technology from an external entity, or being able to even license it to a startup that might start? Sort of an open question to all 3 of you. How could the community as a state help in your growth and development of your products? So open question. Anybody's welcome to unmute and bring up. Tom, I see that you're the first with the trigger to make a comment.
Yeah, I can get started. So we appreciate any help we can receive. So kind of like Riley pointed out, where we are at is that we are in the iterative process of testing and redesign and testing, and we have some promising results, but the design hasn't been finalized. And at the same time, we are starting the process of the intellectual property protection, and then the hood itself then needs to be integrated with the ventilation system, with the penetration through the wall and the ventilation system. So there's more work to be done in that area. And of course, the question is, so once Riley is done with his masters, what's going to happen? Who's gonna continue the work, for example? So any students or anybody else who is interested in this topic, we can certainly use the help. And then there's the whole process of bringing the product to the market. So figuring out how to manufacture it. So anybody with manufacturing experience, this product is likely going to be injection molded. So any expertise in injection molding processes will be greatly appreciated, and then bringing the product to the market. So we do work with Panasonic under the non-disclosure agreement. So that's certainly one avenue, is that maybe just Panasonic could manufacture that, but there are other options on the table, and there's been nothing finalized. With Panasonic, there are other options that a company like Panasonic could just be marketing the product, but the manufacturing could be done by somebody else. So it's a model utilized by some companies. So any expertise in then bringing the product to the market would be greatly appreciated also. So we have gone a long way. We have some promising results, but we still have a long way to go, and there are lots of steps left. And like I said, any help will be appreciated in the remaining steps. And I'll stop here. Thank you.
Thanks, Tom. Making some notes there on ways that whether the center can help connect you to some of those within the university system. Obviously, Riley is a graduate student and also a graduate of the undergraduate program, probably knows the professors in terms of senior design projects and things like that. But obviously there is the potential to reach out beyond UAF and into the rest of the university system. Jeff, I see you're muted, and you mentioned about the connection to Schlumberger and other larger multinationals like that. Is there anything on the sort of technical side where those listening in that might be on the academic environment could help?
Well, we've tested the system hundreds of times in oil baths. So we know even the complete system itself. So we know it's going to trigger at a given temperature in an oil bath. We've made it pretty hard so that it can survive going down a kilometer or two of boreholes, of a borehole. So I think we're pretty solid in that regard. The next step is making a gas tight version. We have the concept of one and how to trigger it. It's just sort of, I think the thing we need next is either more money to actually, make a set and fabricate it and test it. And also, getting contacts within the oil industry. Schlumberger would be an ideal company because they send people out to the rigs to collect a single fluid sample at high temperatures. And just the cost of the two people and the time and the equipment, because they're using electronics in a Dewar system, which is expensive to make and maintain, whereas this system, being all mechanical and being made out of titanium, except for the shape memory alloy, is just a nice hardened metal that that don't need much in the way of cleaning or maintaining. So anyhow, I think it would be great to get input from oil industry experts, and a connection through Schlumberger would be great, or some other company, similar type of company.
Perfect, good, great. It's giving me some ideas from the center side. We've got some training opportunities that might help, or how we could partner yourselves all as the academic research with some of the business on entrepreneurial aspects of taking some of these to market of where, and it's something that we've spoken about within the combination of OIPC and Zenderise, of how to take some of the ideas, winners like yourselves, and how to partner them, and to say, okay, we've got there's the scientific engineering experts, how do we partner those with entrepreneurial innovation supported students or experts themselves, and be able to help get them to the market. So there's the two combinations of the scientific engineering focus, and then there's the entrepreneurial focus, just so that it's a combination, or yourselves taking it on and being able to work it into the industry, but understanding people's time and availability, and it might be more practical to have it connected into an MBA program, or a different group of students that could do the entrepreneurial focus with advice from you all as the scientific and engineering mentors. I guess my next question is, what do you see? Oh, actually, I did have a question probably back to Riley, in terms of both. You were recognized through this for your work with Tom as part of this, but also as part of your undergraduate senior design project. As a student going through the university environment and sort of getting involved in sort of research that has a direct impact, and then getting recognized for it, what are some of your insights, and this is sort of an off-the-cuff question, but what are some of your insights into how this can benefit you as a student going through the university environment to be more resilient as you look to graduate and look to go off into the outside the university environment, how has doing undergraduate research and then getting recognized through this, how has that helped you as an individual to grow and develop your skills?
Good questions. So I pursued the Arctic Dual-Hood project with Tom in an independent study type of course in my senior year, concurrently with my senior design project. A lot of the engineering programs here at University of Alaska Fairbanks have a senior or capstone project. That's a graduation requirement. And oftentimes you can select your own. Not all degree programs allow for that. But if you're allowed to select your own, or if you choose to do an independent study and take on research rather than taking another class, there's a lot of opportunity with the professors and research groups that are affiliated with campus to pick a project and get your hands a little dirty and develop some skills and apply some of the textbook work you've been exposed to, regardless of your discipline. I guess I'm speaking as a previous undergraduate engineering student, but I think this applies pretty broadly. And whether your plans after your undergraduate degree are to continue in an academic field and pursue a PhD or a master's or something in that nature, then that sort of first step in your undergraduate degree will give you that'll give you a leg up, and just you'll just get a head start on that, and that's useful. But if that is not your plan, then you have developed a bunch of skills and tools that'll look very good to a potential employer in the future, and just inform you on a lot of different things that you wouldn't get in the classroom. So I found it very useful. Did I miss anything in there, Peter?
No, that was it. I was really just to highlight that yourself as an example, working with Tom, you got recognized for the innovative research that you've done, as you said, in the independent, but also you did that connection and were recognized for the senior design project that you've done. But we wanted to focus on the dual hood today. So I was hoping that you were able to just talk a little bit about how that worked in the academic environment, where you were researching with a faculty member separately from doing something that you were taking as a accredited class for your capstone, which was part of your degree. So I was interested to know that it was an independent research project. You saw that this interested you. You wanted to build upon something, grow your skills, and then it was that passion that you saw. When Tom mentioned he gave you a list of projects, and rather than giving you one, he said, "What interests you? What do you want to put your passion into?" Jeff and Tom highlighted from at the beginning the sort of seeing the need and highlighting that their passion as the faculty members, but to see that you picked this yourself from a list of projects that Tom had. So I was just interested to hear from your side as a student going through this, sort of how you got involved and what different projects you did. So a question then maybe I had back to David as OIPC. Riley, so thanks for that, Riley. Riley and Tom highlighted the licensing side, and is there anything you can add in terms of how an academic researcher's technology might get licensed, whether it's to an external entity or to their own startup? You mentioned on one of your slides the funding that comes in terms of the license revenue and things like that, but how does an academic researcher get recognized if something does get licensed?
Well, it does start from the disclosure, as these researchers have done to our office, and from there we can pursue potential intellectual property, acquiring that, and it doesn't actually have to be even toward patents, but we are taking disclosures related to even trademarks and copyrights. And with that kind of intellectual property, there's power there to then potentially license to partners in industry. And what's, I think, interesting in an academic setting, really, to transfer that technology to the public, to the commercial sector, we really do need partnerships. As the researchers were really reaching out for other expertise, manufacturing requirements, funding, but really to get it out there from the university, we do need partnerships with industry and other entities. So that's where licensing could take place. I mean, the university, it's a nonprofit public university, and so it's not really to necessarily make a profit, but to really transfer the technology for the public benefit. And part of that, though, does need licensing terms and such, because it's like intellectual property, right? We do need to figure out the terms and conditions for transferring or use of this technology from the university to someone else, to another entity. So that's where our office can really help with that, in terms of procurement of intellectual property rights. We have funding for patent applications and obtaining those intellectual property rights, and then also trying to discover potential market and partners for those licenses.
Great, thanks for that, David. I was just hoping that you'll be able to give a bit more of a summary for those listening in, for the process and what are the options, as Tom and Riley are pursuing one direction with both the patent and the licensing, and then obviously Jeff right now is just interested in finding partners outside the university environment. I think it also you highlighted that. So that's obviously something that the statewide entrepreneurial community can help, not just the three of you here today, but other technologies that have been developed by those within the university environment. We have a large research focus within UF-UAS and also across the university system here, and therefore how to make connections so we can take the research that we've developed, which we see a broader impact, and actually make those connections, so therefore it can get out and be used by society and demonstrate the broader impact of the academic research. My question I have here at the very bottom, which I like to always bring up when I have these types of panels, because the panelists themselves may know about each other, but may not have known exactly about the individual technologies. Do you have questions for each other based on what you've heard, or and it's okay if you don't. I always give the opportunity to see if the panelists would like, given what they've heard today, would like to ask each of the others that are presenting. Maybe Kevin, if you've got some questions that you might want to ask the panelists, then please do. And while that's going on, I'm just going to pull up the chat just to see if there's anything else. But otherwise, do either of you, Riley or Tom, have anything for Jeff? And Jeff, back to Riley and Tom from what you've heard today.
Yeah, I'm really excited about Jeff's project. Jeff, thanks for your presentation. And I'm just wondering, what are the opportunities for students, within your research? What level of students are looking for or are working on the project? What would you have to say about that? Thank you.
Yeah, for this project, getting things going, we had let's see, a material science undergraduate student working with me. My collaborator on this project is Dr. Chris Kitts from Santa Clara University. He had 2 master's level students working on it. And then we also had technical help from my technician who worked on it. And we contracted with a person in the deep sea drilling community, basically a tool, they call them tool pushers, people who put all the tools together to send down the boreholes. We had his expertise involved too, to make sure what we produced was going to have a great, very good chance of surviving in the borehole. So we had a range of expertise from undergraduates to graduate students to more technical help. And so with your project, you're you're still working in the, let's say, a cold room environment, and are you trying to mimic other scenarios with humidity and water content of the air coming in and out to try to minimize the amount of freezing on the outside?
That's right. Yes. We have wrapped up most of our work in the climate chamber, and we're currently setting up a real life heat recovery ventilation system, or actually two, to do some testing this winter. But that's exactly right. We've been varying the relative humidity or the moisture content in the air and temperatures through our prototypes inside of a climate chamber. So that's exactly how that worked. A question back to you on the shape memory alloys. Are those like micro electrical mechanical systems that you're using?
No, I mean, it's literally a piece of metal with a hole drilled through the middle of it. And it's just, you can crush them, or not crush them, you can shrink them by putting pressure on them, deform them, I guess is a better way of putting it. And then as the temperature rises to the activation temperature, it slowly gets back to form. And the way we've got it set up, once it reaches a certain threshold, it triggers the sampler.
Cool. Is that something you and your team have been able to fabricate yourself, or are those outsourced?
We outsource those from a private company. There's in the aerospace industry, they use those a lot. Most satellites will have a shape memory alloy trigger mechanism, and the way they trigger them is they apply power, which heats it up. It acts as a resistor, and once it heats up, it breaks a bolt and releases, for example, solar panels. Pretty much anything that goes up with solar panels has a shape memory alloy trigger mechanism in it.
Okay.
Very cool. Interesting to see something that goes down a borehole also goes up to space.
Yeah.
Full spectrum from the Earth to space and back. It's so interesting to me when you see things that cross, while it is an engineering solution, cross some very significantly large industries, as you pointed out, Jeff, the Schlumberger funding size, but then the number of spaceborne launches that we're now seeing, from everything from these traditional federal agencies to the commercial ones and beyond, and the large scale planetary missions. So it was interesting to see doing technologies that span from one type of engineering problem set to another one, because it is a applicable tool that can benefit all of the different industries. Cool. Well, we've got about 10 minutes or so to go. The final part of today is just going to be talking in general about the rest of Startup Week. But I just want to thank Riley, Tom, and Jeff for their time today to talk about their technologies that they've been developed and been recognized for at the Office of Intellectual Property and Commercialization. You can find more information about their projects on our ideas website. You can connect up with David in terms of learning more if you're interested in collaborating and connecting to Tom, Riley, and Jeff, or just more interested in the actual technology and what they've disclosed, and then reaching out to David, you can do that. So just to finish off, unless David, you've got anything extra you'd like to bring up on ideas and the office, I'll jump on to what we've got coming through during Alaska Startup Week.
I'd just like to thank the panelists for sharing their research and coming on the panel. Really appreciate it.
Good. Yeah, I thoroughly agree, and it's great to hear the developments they've done. I've sort of been involved in the periphery working with David on this, so it's great to hear how everything's developing and going. So what's coming for anybody listening in? Alaska Startup Week, as I said, is about 40 to 50 events going on across Alaska. This is just a highlight of what's occurring today. So for anybody that is able to make it, there is we would traditionally have a kickoff event on a Sunday evening, but that ended up getting cancelled. So the kickoff event is tonight. So if you're able to make it, there's a online and in person for those in Anchorage, online for those not. event, and then there's going to be a presentation by an entrepreneur after that. Then tomorrow we'll have 3 events based out of the Fairbanks and the interior region. We'll have one talking about seed funds, which is one of the aspects within the center, and recognizes some of the researchers here have received funding from within Center ICE. So there'll be different people that have received seed funding. We have a couple of our students to startups, students coming to talk. So anybody interested in learning about what it's like to work within a startup business and the ways that Center ICE can support students in an internship if they're looking to work within a startup company in Alaska. There will be an in-person event at Norween Library on business startup funding 101 with Small Business Association, the Fairbanks Economic Development Corporation, Small Business Development Center, and Northern Bank. And that's from 12 to 1. And then at between 1 and 2, we have one of the UAF-based companies, Be Cool Pharmaceutics, and its CEO, Kelly Drew, and she's licensed technology that has been developed at the university and has gone on to get Small Business Innovation Research grants and is growing her business. So there'll be the chance to hear from her for an hour. She'll talk about her growth and the development of her business. And then we've got 3 events again on Wednesday. We've got presentations by Department of Defense's innovation cells later on in the week. And then for those listening and online that are able to make an in-person event on Friday evening, and you've got that idea that you've sort of been remunerating around in your head, you're thinking maybe I could work on this, and you want to connect up with some interested groups. We have something called the Nook Tank that Kevin will be sharing with Residence Life. So if you can get into the university more Bart Scarlett facilities, then you'll be able to get involved with that. So the week of Startup Week is to talk about programs to highlight entrepreneurs and innovators. We had here 3 within the university environment, the different technologies, the opportunities that come from disclosing technologies that could either be licensed to businesses or move out into commercial opportunities. It could be that you're licensing it to an existing business. Tom and Riley spoke about that connection to Panasonic, where they may license it, or they may want to promote and sell something licensed from another organization. You might start up a business. We saw Kelly Drew that she started up a business here in the state of Alaska to commercialize and license the technologies she's developed. It could be that you're looking at, you've developed something in your scientific research, engineering research, and you think that there's an interest in the commercial sector. We've got support here within Center ICE that could help you do some of that customer discovery, that early evaluation of like, well, actually, does the industry really need and have a challenge that my solution is looking to develop? So that so in those different aspects, please do reach out to us at Center ICE. So I just want to say thank you for everybody listening in today, our panelists presenting, David for helping us on co-chairing from OIPC, that this is part of Alaska Startup Week. For those listening in, there is a feedback form which Kevin will be sharing in the chat. And if you want to attend an event later on in the week, please go and look at the Alaska Startup Week's website.